Here's an example showing, well, asking us to graph y equals the tangent of 3x plus pi over 2. In the reading, you would see that the graph of the tangent function has these asymptotes, and this general tangent function graph looks like this. It doesn't have a max or a min. So if there's a number in front of tangent, it'll vertically stretch it, and we'll see that in some examples, but in this example we don't have to worry about that. There's no amplitude thing happening here. I should label that this is pi over 2 and this is minus pi over 2. That's because the tangent does not exist. Tangent of pi over 2, if you look at your unit circle and try and figure it out, you'll find you get a 0 in the denominator of a fraction. Sine of pi over 2 over cosine of pi over 2, that's 1 over 0. That's undefined. And that's why the graph has this vertical asymptote at pi over 2, and it's the same thing at minus pi over 2. It is cyclic. In other words, it will continue again, and there'll be another asymptote over here. The period, what's the period between minus pi over 2 and pi over 2? What's that distance? Well, it's 2 halves of pi, isn't it? So the period for a tangent function is not 2 pi. It's only 1 pi. Pi over 2, and this will be 3 pi's over 2. That's, if you add 1 pi to pi over 2, you get 3 pi's over 2. So that's what the tangent, y equals tangent of x looks like. But we're being asked to graph, so I'm going to shrink that, get that out of the way here. That's the standard tangent function, just so we have it on hand. And so when we do a laundry list like I had us do on the last two examples, it's going to change a little bit. We'll want to know it's not really amplitude anymore, it's vertical stretch, and in this case we don't have it. I'll write vertical stretch. In this case, there's nothing to worry about, so I just say none, because there's no number in front of the tangent. Period. Remember, on the period for the sine and the cosine, we had to take this number 3 and put it under 2 pi. And the reason we put it under 2 pi, that's the standard period for sine and cosine. But I just got through saying for tangent, the period is pi. So the period here is pi over this number. Let me highlight it. If you here, pi over that number 3. That's the period in this case. So, and then we'll have a phase shift. Let me just write what the phase shift here. The phase shift works the same way as it did with sine and cosine. You take the pi over 2 and put it over that number in front of the x. Pi over 2 over the number in front of the x. Well, that means pi over 2 over 3. Well, what does that reduce to? Well, you could flip and multiply. That's 3 over 1. That's pi over 2 times, let's see, if I flip that, that'll be 1 over 3, and I get pi over 6. So that's the phase shift, and because it's a plus, it's in the minus direction. So I should have had that minus all the way along, really. But it's in the minus direction. So we'll have to deal with that, and we have to deal with a period of pi over 3. So how does that look when when the standard period is pi, and it would normally go from minus pi over 2 to pi over 2? Well, I'm going to draw a standard. I'm first going to just deal with the period. I'm going to draw a standard tangent function. And the distance here was normally pi, but now I've got to split, the distance here was pi up in this example. Well, here the distance is the period pi over 3. If I cut pi over 3 in half, remember how to do that? You just multiply it by 1/2. That means I'm going to have pi over 6 to the right and pi over 6 to the left. That means this is pi over 6 here, and this is minus pi over 6 here. That's as hard as it is. Once you've determined the period, how do you graph it? Well, that's what you'll be putting in there. And then we've got to shift it to the left by pi over 6. That's the phase shift. that means, you know, if I were to select this, if I can, let's see, I would have to move it to the left such that this little cross point here goes over a distance of minus pi over 6. Well, let's see if I can make that happen here. Almost. Am I getting it? There it is. So what was the y-axis here, what was the y-axis is now a vertical asymptote. And what was a vertical asymptote at minus pi over 6 is the center of the graph. So I don't have an asymptote here anymore is what I should be saying. And I do have an asymptote here, so I got to turn that into a dotted line. What am I labeling that? Well, it's halfway between minus pi over 6 and pi over 6. That's where normally the y-axis is. The y-axis is itself, it's still there. It's just now an asymptote. And then if that's a distance of pi over 6, and this is minus pi over 6, and then I've got another asymptote here, another distance of pi over 6 away. I think I drew that too far over. Get that in there a little closer. Okay. Well, that distance of of pi over 6 on either side of this marked middle point here, minus pi over 6 minus another pi over 6, that makes that minus 2 pi's over 6, which is minus pi over 3. So there we have it. This is no longer an asymptote here. See if you can determine what it's going to look like. It's just going to come through again here, right? And come up. It's just going to repeat. And we should always mark a couple of cycles of these graphs. So if that's pi over 6 there, and then this is another pi over 6, that's 2 pi's over 6, becomes positive pi over 3. That is the graph of the tangent of 3x plus pi over 2. The pi over 2, remember what it did? If I put it over down here, if I put it over over the number in front of the x, the 3, it gave me this phase shift of pi over 6. That's how we determine the phase shift. And then that period, that number 3 in front of x is not the period, but if I put it under the period of a standard tangent, which is a period of pi, that's indicated right here, the standard period. Anyway, so there it is. That's the final graph that we circle.